Problem number 1. Suppose the right side of the equation in the example problem is 2x minus 3 plus 8. How many solutions would the equation have? Explain. So the first part of our equation is 2 parentheses x plus 2 plus 1. Then we're changing the right side of the equation to the part of the problem, 2x minus 3 plus 8. So I'm going to start by solving this problem by distributing both the number to both parts of the parentheses, and I get 2x plus 4 plus 1 equals 2x minus 3 plus 8. I can then combine my like terms, 4 and 1, and I would get 2x plus 5. And I can also combine my like terms, minus 3 and plus 8, in which case I would also get 2x plus 5. 2x plus 5 equals 2x plus 5, and so I would have infinite solutions. Problem number 2. Suppose the right side of the equation in the example problem is 3x minus 3 plus 6. How many solutions would the equation have? Explain. So again, I'm taking that 2 parentheses x plus 2 plus 1, and it's going to equal 3x minus 3 plus 6. So again, first step is to distribute to both parts of the parentheses, and I get 2x plus 4 plus 1. I'm going to go ahead and combine my like terms again, 4 and 1, and I get 2x plus 5. And when I combine my like terms on this side, negative 3 and 6, I get 3x plus 3. Now, since my coefficients, 2x and 3x, are different, I know that I'm going to have one solution. Problem 3. Look at the model at the right. Does it represent an equation that has one solution, no solutions, or infinitely many solutions? Explain how you know. So instead of the model, I'm going to write an equation. So I'm going to have 2x plus 2 equals 1x plus 3. I know that I'm going to have one solution because the coefficients are different. Problem number 4. Consider the equation cx minus d equals 2x plus 4. Replace c in the equation with 2. So I'm going to have 2x minus d equals 2x plus 4. For what value of d, so I got to figure out what d is going to be, would the equation have infinitely many solutions? Explain. So when we have infinitely many solutions, I need it to be the same on both sides. So if one side is 2x plus 4, then I need the other side to be 2x plus 4. However, if you look, I have a minus sign here. So I need the equation to be 2x minus negative 4. Because when we do subtract negatives, we would keep change, and so it would become 2x plus 4. So d needs to equal negative 4. Letter B. Replace d in the equation with 2. So I'm going to have cx minus 2 equals 2x plus 4. It says, for what value of c would the equation have no solution? Explain. So to have no solution, the coefficients have to be the same. So that means if our coefficient is 2 on this side, it needs to be a 2 on this side. So that means that c would have to equal 2. So the equation would be 2x minus 2 equals 2x plus 4. Problem number 5. Evelyn says that the equation 3 parentheses x minus 3 plus 5 equals 3x plus 1 plus 4 has infinitely many solutions because the variable terms on each side are the same. Do you agree with Evelyn? Explain why or why not. So we would first distribute our 3 to both parts of the parentheses, and we would get the equation 3x minus 9 plus 5 equals 3x plus 1 plus 4. We could then combine our like terms, negative 9 and 5, and we would get 3x minus 4. And then we could also combine the 1 and the 4 and get 3x plus 5. Now, these are not infinite solutions. So no, I don't agree with Evelyn. Because the same coefficient means no solution. To be infinite, they have to be exactly the same. And this is 3x minus 4 and 3x plus 5. Number 6. Explain why the equation 5 parentheses 2x plus 1 minus 2 equals 6x plus 5 has only one solution. Then find the solution. So first step would be to distribute to both parts of the parentheses. You would get 10x plus 5 minus 2 equals 6x plus 5. I would combine my like terms, 5 minus 2, and I would get 10x plus 3 equals 6x plus 5. Now, I know it's one solution because the coefficients are different. It's one solution because the coefficients are different. Now, if we keep solving, we can find the answer. Now, I'm going to combine my like terms, so I'm going to subtract 6x from both sides. When I do that, I get 4x plus 3 equals 5. I subtract 3, and I'm left with 4x equals 2. And my last step is to divide both sides by 4. And my answer is x equals 1/2. Okay, I went ahead and erased that just so I could have some more room down at the bottom. Number 7, it says write an equation that has one solution, an equation that has no solution, and an equation that has infinitely many solutions. Each term should have one variable term on each side and a total of 4 terms. So basically, if we need each side to be a variable, and then each side needs to have a constant as well. So on each side of the equal sign, you'll have a variable, so that's 2, and then 2 constants. That's a total of 4 terms. So to be one solution, I need the coefficients to be different. So I'm going to do 2x plus 3 equals 4x plus 6. My coefficients, the 2 and the 4, are different. For no solution, I'm going to pick a problem that have the same coefficients. So in this case, I'm going to pick 7x minus 2 equals 7x plus 1. The coefficients are the same. And then for infinite solutions, the entire problem needs to be the same. And so I'm going to pick 10x minus 6 equals 10x minus 6. They have to be exactly the same.